This is the practice test walkthrough for Chapter 14 on solutions and mixtures. For the matching, just vocab, so I'm going to just go through the correct answers. Dissociate is what happens to ionic compounds when they dissolve in water. The ions actually break apart into separate ions, which are then dispersed throughout the water. They dissociate. The bonds are broken between them. Saturated is what we call a solution that cannot dissolve any more solute. It has reached the maximum amount of solute that can be contained at a particular temperature, pressure, and volume of solvent. An aqueous solution is a solution where the solvent is water. So any solution where water is the solvent is called an aqueous solution. Colligative properties are physical properties of solutions that are dependent on how many solute particles are dissolved in it. They are not dependent on what those particles are made of. And finally, the solute is the thing being dissolved, the substance that gets dissolved, and the solvent is the substance that does the dissolving. It's whichever substance there is a greater amount of in the solution. So again, more vocabulary on the multiple choice here. A mixture containing particles that do not settle out if left undisturbed is called a colloid. Okay? A suspension is a mixture where the particles do settle out if left undisturbed, and then solute and solvent are just parts of a mixture. A blank solution contains more solute than a saturated solution. Well, it's not saturated, since that's more than saturated. It is actually supersaturated, super meaning more than or greater than. So supersaturated solutions have more solute than a saturated solution. Suspended is not really related, and unsaturated means it has less than a saturated solution. Two liquids that are soluble in any proportion are called miscible. Okay? Immiscible would mean that they are not soluble. They can mix, but then they separate. And then insoluble and soluble are just more general terms for anything that will not dissolve in the case of insoluble or would dissolve in the case of soluble. A or N blank solution contains the maximum amount of solute for a given volume, temperature, and pressure. That is a saturated solution. It has reached the maximum. Supersaturated is more than that. Unsaturated is less than that. Okay, explain why increasing the surface area of a solute increases the rate at which solvation occurs. This is a short answer question. The key concept here is that anytime you increase the number of collisions between solvent and solute particles, you're going to make it dissolve faster. It's going to increase the solvation rate. So all of the factors that we discussed, whether it was surface area or temperature or agitation, they all work to increase the rate of solvation by increasing the number of collisions. Surface area does that by exposing more particles to the solvent. Okay, then more collisions can occur because there's more exposed solute particles. And if you need to write that down, you can pause it here for a minute, and then we're going to move on. Draw a picture depicting a sugar molecule dissolving in water. Be as specific as possible, showing charges and polarity. Okay, really, this can be a fairly simple drawing. The key here is that you have sugar molecules, which are the bigger molecules in there, and those sugar molecules are each surrounded by these little water molecules. The water molecule would be more of them, of course, but just as a simplified drawing, you've got water molecules surrounding the sugar molecules, and then the other key factor here is that the water molecules are separated from each other. As you can see here, they're all sort of insulated by these water molecules, but the actual molecules remain intact. They are not broken down into their component atoms, unlike an ionic compound, which actually does dissociate into individual ions, positive and negative. That doesn't happen with a sugar molecule or any other non-electrolyte. What is the percent by mass of a 48.7 grams of sodium chloride dissolved in 92.4 grams of water? Okay, well, percent by mass, we take the mass of the solute and divide it by the mass of the solution and multiply by 100 to make it percent. Well, so here we've got 48.7 grams of sodium chloride, and we're going to divide that by the mass of the solution, which is 141.1 grams, and then multiply by 100. Why did I use those numbers? Well, 48.7 is the mass of solute, and the mass of the solution, you have to remember that it includes both the solvent and the solute. So I have to add the mass of the water and the mass of the salt together to get the total for the solution. and then we do that out and we get 34.5%. What is the molarity of a solution that contains 201.54 grams of calcium fluoride dissolved in 400 milliliters of solution? Well, we need to remember that molarity is the number of moles per liter. So first, since we don't have moles, we have to get the number of moles by converting from grams to moles. Right? The mass we're given, the grams, divided by the molar mass of the compound. So the number of moles is the 201.54 that we were given, divided by 78 grams per mole. That's the mass of a calcium and 2 fluoride ions put together. Divide that out. It's 2.58 moles of calcium chloride, or calcium fluoride rather. And that 2.58 moles is diluted or dissolved in 0.4 liters. 400 milliliters is 0.4 liters. Whenever you're going from milliliters to liters, you move the decimal 3 places to the left. Okay, so sometimes when you're doing molarity, you have to put it in liters. When you're doing a dilution equation, which we'll do on this test as well, you do not have to have it in liters. If it's given in milliliters, you can just keep it that way. But if you have to convert from milliliters to liters, you move the decimal 3 places to the left. Okay, so 2.58 moles divided by 0.4 liters is 6.45 molar. How many grams of H2SO4 sulfuric acid are present in a 75 milliliter sample of a 0.3 molar solution? So this is the molarity again, except that instead of finding the molarity, we've got the molarity and we need to work back, we need to work back to grams. First we need to work to moles, and then we can go from moles to grams. So we've got 0.3 molar is a certain number of moles in 0.075 liters. Again, move that decimal 3 places to the left to go from milliliters to liters. So multiplying across there, we get 0.3 times 0.075 moles, which is 0.0225 moles. And 0.0225 moles times 98 grams per mole, which is the mass of H2SO4, if you added all those up, gives you 2.21 grams of sulfuric acid in that sample of solution. Okay, this is the dilution problem. Okay, a 102 milliliter sample of 12.1 molar HCl, that's sort of the way it comes from the supplier, very concentrated, is diluted to 294 milliliters. What is the molarity of the dilute solution? So we've taken a certain amount of concentrated acid, we've added more water, so we're diluting it, and we want to know what's the new concentration. Well, the way to figure this out is that the starting molarity times the starting volume is equal to the final molarity times the final volume, and we've got M1V1, and then we've got the final volume, which is V2. So we need to find that M, the missing molarity, the final molarity. So 12.1 times 102 equals final molarity times 294. Divide that out, and we find that the molarity is 4.2. Okay, it was the volume was roughly tripled, not quite, but almost tripled, which means that the molarity should have been cut in a third or by 2/3, depending on how you want to say it. So that's about right. That makes sense. Okay, a mass of 142 grams of magnesium chloride is dissolved in 525 grams of water. What is the molality of the solution? Okay, molality is similar to molarity, except it's moles per kilogram rather than moles per liter. So we're going to do very similar calculation. We've got the grams though, so we need to get the moles first. So 142 grams divided by 95.3 grams per mole. That is what magnesium chloride would weigh. And that gives us 1.49 moles of magnesium chloride, and it is dissolved in 525 grams, which, to get from grams to kilograms, just like going from milliliters to liters, we have to go 3 places to the left with the decimal. So 525 grams is 0.525 kilograms, and 1.49 divided by 0.525 is 2.84 molal. That's how we say that. All right, the mole fraction of a solution made by adding 150 grams of copper chloride to 400 grams of water. Well, the mole fraction is the number of moles of solute divided by, that should be moles of solute plus moles of solvent, plus, not divided by, it's plus moles of solvent. Okay, so first we have to convert both of these things to moles. Okay, and moles of copper chloride, it would be 150 divided by the mass of CuCl2. You'd add all that from the periodic table. Comes out to 1.31. And then the denominator, 400 grams divided by 18, gives me 22.2. So the denominator is 1.31 plus 22.2. The numerator is just the 1.31 because that's the solute. This is the solute plus the solvent. Plus. And you do all that out, and it comes out to 0.0557. Okay, freezing point depression. So we're going to find the new freezing point of a solution compared to the pure solvent. So calculate the freezing point of a 1.67 molal solution of potassium chloride in ethanol. So ethanol is our solvent. This is not water, it's ethanol as the solvent. Alright, so the formula for freezing point depression is that the change in the freezing temperature is equal to I, which is the number of particles, times the Kf, which is going to be up here in our table for ethanol, times the molality. So KCl is an ionic compound, potassium chloride, so that means that it's going to dissociate, and there are two things here, so it's going to have an I of 2. Well, Kf is found by looking up ethanol in the table. The Kf for ethanol is 1.99, and then the molality is given to us in the problem. It's 1.67. So we have all the numbers that we need. We plug those into the equation. 2 times 1.99 times 1.67, and so the change in the freezing point is 6.65 degrees. But that's not what the question asks. The question asks, what is the freezing point? So we have to take a look at the original freezing point, which was negative 114.1 Celsius, and then lower it by that number. So negative 114.1 minus 6.65 is negative 120.75 degrees Celsius. That's the new freezing point of the solution. All right, and then a boiling point question, similar. It's going to be almost the exact same formula, except we're using change in boiling temperature and the boiling point constant rather than those for freezing. And this is working a little bit backwards as well, because what they do is they give you the new boiling point and then ask you to calculate how many grams of solute were added to a certain amount of water. So it's an aqueous solution. Well, we're given the change in boiling point, because water normally boils at 100 degrees, and this says it boils at 105.3. So the change was 5.3 degrees Celsius. That's our delta TB. This is a non-electrolyte. It's a carbon compound. It's a sugar. So the I is going to be 1, and then we're trying to solve this for water. So the Kb, the boiling point constant, is 0.512. And then we need to find the molality. So we're going to plug all the numbers that we have. 5.30 equals 1 times 0.512 times m. So it would be 5.3 divided by 0.512, which is 10.35. That is the molality of the solution, but the question asks how many grams were added. So we have to work backwards a little bit more. All right, so 10.35 molal, remember molality is moles per kilogram. We had 200 grams, which is 0.2 kilograms. So the number of moles of sugar here would be 10.35 times 0.2, which is 2.07 moles. We're not there yet. We have one more step to go, because we need to get from moles to grams. That's what the question wants. So 2.07 moles from the last step. Converting that to grams, we would do 2.07 moles times 180. That's the mass of glucose. 2.07 times 180 is 372.6 grams. So you would have to dissolve 372.6 grams of sugar in 200 grams of water, which is 200 milliliters, so a fifth of a liter, and then it would boil at 105 degrees Celsius. So it takes a lot of sugar to raise the temperature by a few degrees. And finally, oldie but goodie, what is the name of the compound CuOH2? Well, Cu is copper and OH is hydroxide. There are two hydroxides. Hydroxide has a charge of -1, which means the total negative charge is -2. So the total positive charge has to be +2. Copper is one of those transition metals, so we need a Roman numeral in there. Copper 2, which means the copper has a +2 charge, and that should be hydroxide. Okay, so copper 2 hydroxide would be the answer here. So just for quick reference, you will get those constants, the tables for boiling and freezing point on the test, just like you were here. But again, just like on the practice test, you will not be given any of the formulas. You need to know molarity, molality, dilution equation, percent by mass or volume, mole fraction, and the formulas for boiling and freezing point change, boiling point elevation and freezing point depression. All right, so we will see you soon.